Hello everyone. In this next unit, we are going to start shifting our attention to algebraic expressions. And algebraic expressions are expressions that contain at least one variable. And in those expressions, you're going to have several terms. Terms can be a number, they can be a variable, or they could be a product of a number and a variable, such as 2 times x times y times z. And you're going to see expressions separated by plus and minus signs. Like terms are terms that have the same variables and same exponent. So, for example, 3x and 5x are like because they both have an x in them. W and w divided by 7 are like because they both have a w. 6 and 22.4 are like because they are both numbers. Unlike terms are terms that have different variables or different exponents. So one example would be 5x squared and 3x. They both have the same variable, but they have different exponents. So they are unlike terms. 6a and 6b are unlike because they have different variable terms. And of course, 3.5 and n are different. They're not like terms because one is a variable and one is a number. So shift your attention over here to the left. How many terms are in the expression 2x cubed plus 5yz minus 7? Well, there are 3. There's 2x cubed, there's 5yz, and there's negative 7. Remember that when we have subtraction in a problem, we can rewrite that as addition. So if I wanted to rewrite this expression, I could write it as 2x cubed, and that just means to the third power, plus 5yz plus negative 7. Remember that minus 7 is the same thing as saying plus negative 7. So now we can easily see that there are 3 terms in this expression. And what are the like terms in the expression here? 2x plus 5x squared minus 7x plus 1. Well, that's just 2x. And that would be a negative 7x. 5x squared and 1 are not like. So let's identify some like terms. And this should be mostly a review for you from 6th grade. But let's go ahead and separate these into groups. Let's look at my A terms first. Well, I have a 5a and a 2/3 a. Okay, let's move to t, because that's the next one in our list here. Any t variables? Well, we have, or t terms, we have t divided by 2, we have 7t, and 2t. Okay, how about some y terms? Well, with our y terms, we have 3y squared, and we have 4.5y squared. And then finally, all that we have left is a x squared term, a 4z, I'll do that in a different color, a 4z, and a k term. There are no like terms there. So go ahead and pause the video here and try the your turn number 1 problem. Okay, so you should have had a chance to work on the your turn 1 problem. So let's look and see what like terms we have. For our t terms, we have 3t and 7t. We also have terms that have a w in them. We have 5w squared, and 4w squared. And then we have some v terms, 9v and 8v. So good. So we have sorted out our like terms. Well, let's see what happens when we combine like terms. Let's look at our first example here, 7x plus 3x. When we add our like terms together, we're going to add their coefficients, which remember is the number that comes before the variable. We talked about that in the last unit. So if I have 7x's plus 3x's, that means I have 10x's total. For question B, we have a much longer expression. We have 5x cubed plus 3y plus 7x cubed minus 2y minus 4x squared. So when I simplify my expressions, I like to go through and underline the ones that are similar to each other first. So 5x cubed, 7x cubed. And then we have this negative 4x cubed. I'm going to give that 2 underlines. And there's no other term like that, so I won't be combining that with anything. And then I've got 3y and negative 2y. So I'm only going to combine the terms that have the same underlines. If you want to use boxes, circles, other different types of use squiggly lines, whatever works for you to be able to sort them out as you are combining your like terms works fine. So let's look at our x cubed terms. So again, we have 5x cubed and 7x cubed. If I add 5 and 7, that means I have 12x cubed. Next is going to be my minus 4x squared. We already said there's no other term to combine with that. And we have our y terms, 3y and minus 2y, 3y and a negative 2y, which gives us a positive 1y, or just leave that as y. Go ahead and pause the video here and try the your turn 2 problems. Okay, let's review. 6t minus 4t, well 6 minus 4 is 2, so that's 2t. For b, you should have underlined 3a squared. It has no other like terms. And 11b squared also has no other like terms. 5b and negative 4b, I'll give 3 underlines. And 6, I'll give 4. Notice I'm kind of going in alphabetical order here. And I'm also going from highest exponent to lowest exponent. So 3a squared plus 5b and a negative 4b. Oh, actually, we're going to put our b squared term first, plus 11b squared. And then 5b and minus 4b make 1b, and that's positive. And then the plus 6. Now let's look at simplifying linear expressions. With addition, the rules don't change. You are still going to add up your like terms. And really, you're kind of going to ignore the expressions. Or sorry, you're going to ignore the parentheses. All we're saying here is I have an expression here, and I want to add those two expressions together. But I'm just going to combine my like terms like I've been doing. So for a, I have a 3x and a 5x. That makes 8x. And I have 1/4 and negative 2 and 1/4. And if I add those together, that makes negative 2. So we have 8x minus 2, and we simplify that. We can do the same thing for b. 3x and 7x make 10x. And a positive 1/2 and a negative 4.5 just make negative 4. So notice we didn't change anything different. The parentheses didn't throw anything off. All we're saying is we're adding two expressions together. And it's the same thing as combining like terms. Now with subtraction, there's one step that you need to do here before you do anything. We're subtracting two expressions. Taking this expression here and subtracting it by this expression. So when you subtract, there's a few things I want you to do. We're going to add the opposite, just like we did when we dealt with integers. So the first expression stays the same. Change the subtraction to addition, and then change the sign of everything after it. These two expressions that we have, the one that was given and the one I just wrote in purple, are equivalent expressions. Remember, subtraction just means we're adding a negative, and that's what we're doing here. Instead of subtracting the quantity of 1.8x plus 2.1, we're adding negative 1.8x minus 2.1. We're just adding the opposite. Now we can go ahead and combine just like we did with addition. Negative 0.35x and negative 1.8x. That comes up with negative 2.15x. And then minus 2 and minus 2.1, that's minus 4.1. Pause the video here and see if you can do example B. Okay, let's recap. So the first thing you should have done is you should have rewritten your expression to an addition statement. So the first part stays the same. Change the subtraction to addition, and then change the sign of everything after it. Now we can combine our like terms. Negative 0.25x and negative 1.5x make negative 1.75x. Minus 3 and minus 1.4 make minus 4.4. The linear expressions take a little bit of practice. So take your time with them and just make sure that when you're subtracting, you're just changing it to an addition problem and then changing the sign of everything that comes after it. Let's talk about the distributive property. This is also a review of last year, but let's look at what the distributive property is. Remember that the distributive property means that we're going to take the outside term and multiply it by everything on the inside of our parentheses. So when we're looking at C here, I'm taking 2 times 5a plus 2 times 4b. So we have 2 times the quantity of 5a plus 4b, and I can distribute that 2 to each term. And when I say distribute, I just mean multiply. So 2 times 5a gives me 10a, plus 2 times 4b gives me 8b. It does work with fractions as well. So look at example D. We can distribute this 3/4 to 8a, 16b, and 20c. So 3/4 times 8a plus 3/4 times 16b minus 3/4 times 20c. And of course, you could have changed this minus to plus a negative 20c if you wanted to. So 3/4 of 8 is 6, so that's 6a, plus 3/4 of 16 is 12, 12b, minus 3/4 of 20 is 15c. Pause the video here and see if you can come up with the answers to your turn 5, E, and F. Okay, let's recap. So for E, you're distributing that 7 to the 9k and to the 6m. So you should have gotten 63k plus 42m. And for F, we're distributing the 2/3 to the 6e. We're distributing it to the 9f. And we're distributing it to the 21g. 2/3 of 6 is 4. 2/3 of 9 is 6. And 2/3 of 21 would be 14. So 4e plus 6f minus 14g. Finally, let's look at factoring. Factoring is the opposite of distributive property. Instead of multiplying through, we want to pull out a greatest common factor, or GCF. Okay? And that greatest common factor is going to go on the outside of our parentheses, and then we'll divide through. So let's look at A here. The greatest common factor of 4 and 8 is 4. It's the biggest number that will go into 4 and 8 evenly. So I'm going to place a 4 on the outside of my parentheses. And on the inside, we'll divide through. Well, if I divide 4x by 4, that just leaves me with 1x. And then if I divide 8 by 4, that just leaves me with 2. If I want to factor 2x plus 2, I'm going to pull out the greatest common factor of 2x and 2, which is 2. So the 2 is going to go on the outside of the parentheses. 2x divided by 2 is just 1x, plus 2 divided by 2 is 1. Okay? And of course, you can check these by distributing through and just making sure that you factored correctly. So 4 times x is 4x, 4 times 2 is 8, so that's correct. And 2 times x is 2x, plus 2 times 1 is 2, so that's correct as well. All right, go ahead and pause the video here and try the Your Turn 6 problem. Okay, let's go ahead and recap. So the greatest common factor of 3x and 9 would be 3. So that's going to go on the outside of my parentheses. 3x divided by 3 would be just 1x. And 9 divided by 3 would be 3. For B, the greatest common factor was 5. That'll go on the outside of the parentheses. 5x divided by 5 is 1x, and 15 divided by 5 is 3. And of course, remember, you can check 3 times x is 3x, 3 times 3 is 9, that checks out. 5 times x is 5x, and 5 times 3 is 15. So those are correct. You will need to finish the challenge question right here on your own, and you will also need to complete the summary. Fill in the blanks, and we will discuss as a class tomorrow.